Here we go with Chapter 12, looking at the skeletal system. You have 206 bones within your skeleton, and I like showing this picture because it gives you the very basic rendition of a skeleton and all of those bones, even though it's hard to see the actual individual bones, such that you wouldn't be able to count 206 bones from this picture, but just know that's how many bones there are in our body. But this is a fun chapter. Here we will see what all of the bones in our body look like and really get an inside look at what our bodies, what the structure at the core of our bodies look like. And with just the skeleton, we humans look very different, and we actually look very much alike at that skeleton level. All right, so after this chapter, you've got a variety of objectives that you should be able to go through, and you've got a nice list of those. So we'll just pass on, moving into overall goals. All right, very big picture here. Know how bones look, how they grow, and how they repair. Really specifically, we want to understand the idea of growth and repair. Then understand that bones remodel themselves. So if you think about remodeling your kitchen or your bathroom, all right, you take something and completely redo it, it looks brand new. It's very similar to what is occurring with our bones. And then also, some of you already understand a lot of this, some of you know it, but even if you do, it's a good review on what we should do to take care of our bones. All right, so the function of the skeleton system. All right, support the body. All right, when the average person thinks about the skeletal system, the top two are probably the basic function that come to a person's mind, with supporting the body and protects the soft body parts. All right, but the other three are very important. The production of red blood cells, or blood cells in general, by the bone marrow is quite important, and our immune system would not function if the microenvironment of the bone is not healthy. All right, then when a person is deficient in their calcium and phosphate intake, one manifestation of that deficit can be an easy fracture. All right, the reason for that is that the rest of our body needs calcium and phosphate to function properly, and our bones actually store those minerals. And when the rest of our body gets depleted from those, it starts to draw calcium and phosphate out of the bones. Then at the very end, allows for movement by attaching muscles. All right, so the muscles are really going to be what is causing the movement, but connecting movement back to support of the body. Now you can see how both systems, the muscular system and the skeletal system, are going to be very closely related. All right, now looking at some of the bone structure. The long bones are marrow-filled tubes with spongy bone at the end. And so what this means is that there's going to be bone marrow that is going to function to help with the generation of blood cells. The spongy bone, or the spongy ends, with a growth plate of cartilage. It's important to maintain the proper integrity of that growth plate throughout the period of skeletal growth. Infancy, early childhood, adolescence is when you're going to see the growth of the skeleton. All right, spongy bone does not appear to be as organized. If you compare this picture relative to this picture here, not nearly as organized. The bones have their own blood supply, so just like the heart has its own blood supply, the bones also have to have their own blood supply. Even though there's a lot of bone marrow, there's a lot of blood movement, circulation on the interior of the bone where there's bone marrow, the bone itself, like you see here, has to have its own vasculature for proper nutrient and waste movement. All right, then looking at the rib cage. All right, looking at the bones of the axial skeleton, you have the rib cage that is going to protect the vital organs, all right, with 12 pairs of bones in both genders. So if you recall from the story of Adam and Eve in the Bible, how God takes a rib from Adam to create Eve, all right, for, I don't know, an uneducated, I don't know, folk's tale, wise tale, is that men have fewer ribs than women, but we actually have the same number. So the ribs are going to be flattened bone that originate from the thoracic vertebrae. There's 7 pairs of true ribs, which are going to be at the top, 3 pairs of false ribs, and 2 pairs of floating ribs. The floating ribs don't actually attach at the front, what you see up here. One's here, and then one's here. All right, the rib cage, absolutely important for protection of all of the organs, the liver, the heart, the lungs, that are going to fit in the interior of this. Those organs that are easily damaged if they are hit. All right, you can get hit in the stomach, punched in the stomach. You might get the wind knocked out of you, so to speak. But that is a very tough organ, the stomach, versus the liver, right? Not so tough. You can actually have, it actually is relatively easy to damage the liver if you were to have trauma to the body. And if you ever have the opportunity to, I don't know, play with, pull out a chicken liver or a turkey liver when you are cleaning a chicken, a whole chicken or a turkey, all right, just mess with the liver and see how soft it is and actually how squishy it is. And if you imagine taking a hammer to that or a large kitchen utensil and just hitting it, right? It's really squishy. It's going to break open the outer coating and you're going to have damage. You don't want that when you're alive, because that's going to minimize the function. And if you damage those interior organs, it's a very good possibility of bleeding out into your abdominal cavity. All right, so then skipping section 12.3, we're just going to move on into the articulations, meaning the joints. The joints are going to be lined with cartilage, and those are structures that are going to allow for really function and movement. And you can see this person here, she as a gymnast is going to depend on flexible joints, and you have a variety of different joints. You have the generalized synovial joint, then you have the ball and socket joint, and then you have the hinge joint. And you can imagine where you might see these. You have the ball and socket joint. This is going to be the shoulder. It's going to be the hip. The hinge joint is going to be the elbow. Elbow is a major one. Here, the synovial joint. This is going to be the most widespread throughout the body. You might think that the knee is a hinge joint, but the knee is actually a synovial joint. And so those really need to be maintained, the health of those joints maintained, so that you can maintain proper function and movement of those joints. All right. Then moving on to the bone growth and homeostasis of the skeletal system. These are interesting cells that we're going to talk about here. And if you think about bone growth and the remodeling process, the repair process, you have 3 major cells that are going to be involved in this. And the next slide shows you a diagram, but real fast. The osteoblasts are bone-forming cells. The osteocytes are mature bone cells that maintain bone structure. And these cells are actually derived from osteoblasts themselves that actually get caught in the middle of the bone as the bone is being made. And then there's what are called osteoclasts. These are going to be bone-absorbing cells. And then you have cartilage that is important because it's going to be the flexible connective tissue that is going to be on the exterior of the bone to help with maintaining structure and also maintaining some of those joints. All right, so this figure is not out of your textbook, but just a very informative picture that shows a timeline of the process of making and remodeling bones, as well as the 3 major types of bone cells, and also their location within the bone. The dip in the middle of the figure represents resorption, and that is when old bone is taken away through the help of the osteoclast. So this guy here is the osteoclast, and it comes in and it secretes enzymes, and those enzymes break down old bone, and the bone is going to be on the surface. It breaks it down, and so here you have resorption, and then you have formation. All right, and the formation are going to be caused by these osteoblasts that come down and lay new bone down, new bone cells. And then in the process of creating this new bone, coming in and filling in this hole, you have osteocytes that are formed. And these are these star-like cells. And what happens is some of these osteoblasts get stuck here, and then more osteoblasts come along on top of it and lay down the actual material of the bone, the phosphate, the calcium, all of those minerals, and the osteoblasts get trapped, all right, kind of like sand or dirt falling on top of someone who was in a hole. Then the osteocytes kind of rearrange themselves in terms of their overall structure, and then they sit in the bone, and they provide basic homeostasis activity within the bone itself. All right, now, looking at bone growth, all right, bones initially grow by replacing cartilage, right? Then they can get longer, and that process is remodeling. All right, so this figure, figure 1211, you want to look over it, and what this figure does is takes you through the process of bone growth, moving from the cartilage point on this side, and you can see the difference. This is completely white. Then you have the developing, or what happens in the developing embryo, to the bone growth of a child. You see over here. So an important feature to make note of is the blood supply that develops midway through this process. So in utero, you have cartilage moving over to bone. Not a whole lot of blood supply, but the bone isn't mature at that point. And as the bone itself starts to mature, then it starts to develop its own bone vessel, its own vasculature, and that's because it's going to need more nutrients. And as the bone matures, then you have a very intricate vasculature component to that bone. All right, then bones lengthen when the osteoblasts build upon the bone, and then the osteoclasts help remodel by degrading that old bone. And so you have this process of degradation and rebuilding happening through both those osteoblasts and the osteoclasts. All right, bone is constantly being repaired, and you can have, this is a major break where you have a hematoma that occurs with this break. Then you have what's called a fibrocollagenous callus that develops. Then you have a bony callus and then you have the remodeling process, and you have finally the healing of that bone.